Welcome to the video key for quiz 1. Okay, so we imagine that we have a piece of hot metal and we're going to drop it into some ice. So you've got a bucket of ice, we've got some ice cubes in here, and we're going to take this piece of metal, and the metal is hot. So it's hot, we said it's at T1. We're going to drop it into the ice, and the ice is already at its melting point. So we can say TM if we want. Okay, we could call it TM. We could call it T equals 0 degrees C. Either one's fine. All right. Now we know that what's going to happen is some of the ice, but not all of it melts. So we're supposed to come up with the expression for the specific heat of the metal. So we start by saying what's going on in the cup. So we're going to melt some of the ice, so we can say Q melt. And we're going to cool down the metal. So we'll say cool down metal. And those are the only things that are happening, right? We didn't see, the ice is not going to all melt. And so we're not going to heat up the ice, because if some of the ice is left, we're just going to stay at 0 degrees C. So it adds up to 0. So now we have to put this into terms of variables that are in the problem. So for Q melting, we've got N. We said we had the amount of ice that melts is N sub 1. Or I guess it's N sub ice is the amount of ice that melts. If we multiply that by the heat of fusion, that will give us the amount of heat it takes to melt that amount of ice. Then we take the metal and we cool it down. So it's going to be the mass of the metal, and that was M sub M, the specific heat of the metal, C sub M, which is what we're trying to look for, and delta T for the metal. And before we solve this, we want to put it all in terms of variables that were given. Delta T is not given, so we need to actually make that a little more specific. So Ni is given. Delta H of fusion is something we can look up on the equation sheet. The mass of the metal was a given variable. The heat capacity is the variable we're looking for, but delta T doesn't match anything, so we got to fix that. So it's a final minus initial temperature for the metal. So let's leave it as T final for now. And we've got the T initial for the metal was, we just called it T1, right? So that was the first initial temperature of the metal. So final minus initial. Okay. And we can go ahead and plug in anything else we know. And one thing we know is that the final temperature has to be 0, right? If we end up with some ice being melted and some ice not being melted, we know we're at 0 degrees C. So we can plug that in. So we can explicitly say this is going to be Tm, the melting temperature for water, which is just C equals 0 degrees C. So we can go ahead and just knock this out since we know it's going to be 0. And so we've got Ni delta H of fusion plus M metal C metal T1, and we got to remember there's a negative sign here, so let's go ahead and put that negative sign in, is equal to 0. So if we move that term to the other side, if we add MCT to the other side, it's going to become positive, right? So we're going to have Ni delta H of fusion is equal to M metal C metal T1, and now we can just solve for our unknown, the heat capacity of the metal. So we're going to divide both sides by M and T. So we get the specific heat of the metal is equal to it's going to be equal to Ni delta H fusion all over the mass of the metal and the initial temperature of the metal. All right, and we'll go ahead and check the units when we do the second part here. So let's plug in our numbers. we said the amount of ice that melted is 0.15 moles. The heat of fusion we can look up, 6,010 joules per mole. And we could leave it in kilojoules, and then our answer is going to have kilojoules instead of joules, but joules are a little bit more customary for this. Our mass of metal, we said, was 40 grams. And the initial temperature of the metal was 45 degrees C. Okay, so notice in this expression that if it took a lot of heat to melt the ice, if N times delta H of fusion is big, right, that would mean that it implies that the metal has a higher heat capacity. So that makes sense. Let's go ahead and plug those numbers in. And that comes up to 0.50 joules. And let's go ahead and cancel the units. The moles cancel moles. So we've got joules per gram per degree C. And that's the units we expect for specific heat. So we're good. And also we can see that's a reasonable number, right? That's something that wouldn't be surprising for a metal. So that's it for the video key for quiz 1. Thank you for watching.